is Visionary, a show exploring how nuclear powers your world. I'm Mary Carpenter.
And I'm Jordan Houghton. Let's jump in.
Hey, Jordan.
Hey, Mary. And hello, Fissionaries. Thanks for tuning in with us again today.
Hey, Visionaries. Thanks for joining us. We have a fun episode for you today with someone from NASA.
We are talking about outer space and beyond with Trudy Kortes, who has spent her career at NASA. And we are able to dive into a lot of different space-related topics. I was really excited for this episode because I love all things space. One thing we talk about is whether we would want to go to space. But I have another question for you, Mary. Would you want to live on Mars?
No, I don't think I would make it. I mean, maybe one day if they build like nice places to live and there's sustainable food and they figure out, I'm pretty sure the weather is pretty bad there. I don't think that I could cut it. I like a modern luxury that I don't think has made it to Mars yet. Unless it is there and we just don't know. Like, what if there's an entire Martian community with like beautiful resorts and awesome like houses? Like they're living like the Jetsons. You never know. Then I could go.
Like Four Seasons Mars?
Yes.
Yeah, exactly. I agree. I don't want to, I would not go. I would not live there. You know, the survive the apocalypse things. I don't want to survive the apocalypse. Like that's not a goal for me. If that happens, just count me out. So yeah, no, I don't do. Again, I think I've said this before. I need nice air conditioned environments. Mars seems to. I watched that. We talk about this a little bit with Trudy, but have you seen The Martian, the movie?
Yeah, and see, that's what I'm talking about. I don't want to do that. I totally respect people who do it and explore all these places that we need to explore, but like I'm not cool enough for that.
No, me neither. And fun fact, which we didn't even talk about with Trudy, is like one of the greatest threats to humans in space is actually cosmic radiation. So that's a huge part of sending people to space, is to make sure they're properly shielded from cosmic radiation.
Yeah, it's interesting too that all of these very wealthy people are putting their money towards going to space just like casually. That's not something, if I was a billionaire, I would probably do. I love watching them and seeing people go to space, but it's kind of the same for me as a submarine. Like, I don't need to go to space. I don't need to go to the bottom of the ocean. Like, I love seeing what they discover, but I'm good on Earth.
Fully agree.
But it is cool. And I don't know if all of our listeners know, but how involved nuclear is in space travel. It's a big part of, radioisotope powered satellites that they're building for the military. It's helpful in surviving the lunar night, which Trudy will touch on. There's a lot of different ways that nuclear is, powering, exploring the next frontier.
Trudy Kortes is the Director of Technology Demonstrations at NASA's Space Technology Mission Directorate, overseeing critical technology advancements for future exploration missions. With more than 28 years of experience at NASA, she has held key positions at various centers and managed significant projects, including those for the Orion spacecraft and the International Space Station. Trudy, we are so excited to talk to you and talk about space today on Visionary. I would love if you could just, in your own words, give us a little bit of background on yourself and what you're working on at NASA.
Yeah, sure. Well, thanks, Jordan. Thanks, Mary, for having me here today. So I grew up in Michigan. My dad was an engineer for Ford Motor Company, and I always did well in school, loved school, but really excelled in math and science. And, got a lot of encouragement from my dad and teachers to consider engineering. And that's what my education is in. So I undergraduate, bachelor's and master's degrees in engineering. And, started out with the agency at Johnson Space Center in Houston, Texas, doing thermal vacuum testing for anything that we flew in space. We would put hardware or people in a chamber and simulate the temperatures and pressures of the space environment. And that was kind of my first start at NASA. And from there, I went on to manage projects and then ultimately programs. And now I manage a program that's a broad variety of technologies that we need for future missions, for future capabilities. And it ranges from anything from entry, descent, and landing technologies, communications technologies, power, propulsion, robotics, autonomy, all kinds of things that we really don't have at our disposal today that we're going to need to do some of the ambitious plans that NASA has for the future.
So we've heard that you've had a fascination with space since high school. Is that true? And what inspired you to pursue your career?
It is. I was a junior in high school in my physics class with Mr. Krupka, if you must know. Everyone loved Mr. Krupka. He was really fun. I can remember doing certain labs, physics labs on, friction and coefficient of friction and things like that. And we were doing a lab one day in physics class, and it was in January of 1986, and the Challenger explosion happened. That was in the days when they wheeled in an audiovisual cart. Several people might not know what an audiovisual cart, but basically is a cart with a TV on it. And they would wheel it in and plug it in. And we spent the rest of that afternoon watching all of the coverage of that. And it might sound strange to some people to hear that an event like that was inspiring to me. But really what I saw in the aftermath of all of that was, I don't know, it just struck me as a professionalism, a resiliency, people who really believed in what they were doing is kind of what I saw displayed to me on TV that day. And my dad, who was a really big influence on me, both my parents were very encouraging. My dad used to always say to me, why don't you really consider going to get an engineering degree? No one can take that away from you. And so I had been thinking about engineering for a while, but there's so many different disciplines of engineering. I didn't really know which way to go. And like I said, I grew up in Michigan, about 30 minutes away from now my alma mater, the University of Michigan. And at that time, in the late 80s, early 90s, Michigan and Purdue would toggle back and forth for kind of number one and number two in the country for aerospace engineering. So it's 30 minutes away, heavily influenced, by my folks, and had a lot of aptitude in those areas. So it was just kind of a natural fit for me. And so that's usually the story I tell about how Challenger inspired me to go on to get that degree and then ultimately work for NASA.
Incredible story, very inspiring. You grew up in a household that encouraged you to be engaged with STEM, which is something that we are seeing given more focus now. And as part of your work, you have made a name for yourself as a STEM speaker. And I'm curious what inspired you to become a mentor for STEM education and specifically women in STEM.
First of all, I do enjoy public speaking. I know that's not something everyone does, but in high school, I did what's called the forensics team, and it's public speech making. And I really started doing it with friends who remain close friends to this day. And it's where I really got comfortable speaking. And it's really a muscle you have to exercise. And then I did it in my first job at NASA giving test readiness reviews. So I love to speak. And it did occur to me at some point that in talking with college students, I'm on the board at my alma mater, and I would go back and talk to college students. And what they tell me from time to time is that they need mentorship. And what I realize they mean by that is when you go to get a degree in say, engineering or a STEM field, you will get the technical knowledge you need in spades. I mean, you're going to get all of that you need. But no one really is talking to you about those things that you really need in your career to even just get by, let alone thrive and advance. And those are things like teamwork and collaboration and good communication skills, all of those types of things, how to get along with other people, different personalities. And so I put together a package called Leadership in an Engineering Environment, and I started giving it different colleges and universities. When I was at Georgia Tech just a few weeks ago, they had a women in STEM type of day. And they actually had students, elementary school students, in an auditorium, and I got to sit in on that. And then they had a broadcast from Communication with International Space Station. And the two astronauts that were there talking to them, two of the female astronauts that are up there right now, And one of them said, and this was in advance of my speech, and she didn't see my speech. And she said, what I really wouldn't do is talk to the students. I would talk to the parents. And it really resonated with me. And I thought, yes, this is the thing. Parents have such a huge influence on what their kids do. And that was evident for me in my home life, and really kind of steered me with my career. So I like to get out there. I like to talk to people, see what their challenges are. And inevitably, they're going to say to me, a challenge is with team leadership when they're on a student team, or interpersonal dynamics. I've never once had someone say to me, could you help me with like my gas dynamics homework or my calculus? But they always say, can you help me? I have this one particular challenge that's completely the soft skill size. We call it the soft skills, but they're really not the soft skills. They're the more difficult things to master. So that's kind of how that all started for me.
I love the idea that you called soft skills actually the critical skills. Those are the harder ones to master. I mean, Mary and I obviously are nuclear communicators. We work with nuclear engineers all the time who know the engineering and the science in and out. But then when we get them, we have to work with them to learn how to communicate that outwardly in a way that all of the non-engineers can also understand. So I love that you are bringing that to the next generation of professionals as something they need to think about and emphasize. I think you're going to make future communicators' jobs easier too.
Mm-hmm.
So something else you've talked about, you're a scientist, you think and you're taught to approach challenges with logic and data, but you've spoken about the importance of listening to your gut instinct, especially when it comes to your career. What does it mean to you to listen to your gut, and how has that helped with your work?
I've always thought that I have a good innate sense, I guess, of certain things. Reading people or a situation, I think that's very important to anyone's workplace. I think your ability to read a room, read a situation, pick up, there are all kinds of either subtle clues or underlying messages, that are happening that really can help you in your career, and being able to get a feel for that or have that feel and use it is really important. So, and it's a difficult thing to talk about, especially at places like NASA or highly technical places that are very data driven and, like you said, logic driven, which they should be, right? In the line of work that we do, we should not ever, for example, take risk in a mission based on someone's gut feeling. That's like, everyone bring data to that situation. But when you're in a interpersonal dynamic situation and reading a room, it gets really important, and it can help you maneuver through your career in ways that surprise me even to this day. But it's just critical. You have to read people. You have to understand people's motivations or try to figure that out. It's a critical skill, and not really one we're talking about, a whole lot.
So before we jump into talking about fission, we want to talk to you and hear your thoughts about the Artemis mission. Mm-hmm. We know it's a historic mission, not only in furthering our exploration on the moon and Mars, but NASA will be sending the first woman and the first person of color on a lunar mission. What has this mission meant to you?
Well, it's really a starting point. We're talking about now the Moon to Mars campaign. And I think the to Mars part is really the most exciting part of that, because that's going to be brand new for us. We've been to the moon, but this time when we go back to the moon, we're using the moon almost as like, on Earth, we have different facilities, environments that we can use to test what we're doing. The moon becomes our test facility now. And we're going to be putting certain technologies there to be able to, first of all, demonstrate them and then use them as infrastructure that we're going to need to prove out first before we go to Mars with those same technologies, which is obviously much further away, much harsher conditions, and to be able to survive there and do meaningful, work, meaningful science, meaningful technology development. So these Artemis missions are a starting point for this longer term plan. And it's great to see this get going, but we have a ways to go.
So in order to properly explore the moon, we're going to need a reliable power source. And NASA's looking at fission reactors as a solution for this. Mm-hmm. I'm really excited to talk to you about this because I lived in Vegas for 15 years and I was there when Krusty was tested on the Nevada National Security Site. I'm going to let you tell our audience about the fission reactors and where we're at with that process, because you'll be able to explain it a lot better than I can. But I'm excited for you to dig into this.
I'm really impressed that you know about Cresty and you're out there at that time. That's great. So, this is a technology that's really going to open a lot of doors for us in terms of what's possible in the future. It's very enabling technology. We're really at the very forefront of developing this, what we call a formulation stage. Fission surface power does come from fission, the fission process, which works by splitting uranium atoms inside a reactor. You're generating heat. Heat's converted to electricity. Not a lot of moving parts with this thing, which is good. They're very powerful. They're very reliable. They're carbon-free, clean sources of energy that, they don't rely on solar or wind to operate. So there's a lot of very unique benefits of that type of sustainable power source, which we're going to need to operate in extreme environments like a lunar environment. Surviving the lunar night is a very difficult thing to do. In kind of those regions in space where we can't use solar, we can't have chemical systems, they're inadequate, or either inadequate or impossible as power sources for extended operations. So we're looking at those types of things to help us really enable kind of those very robust, reliable space operations we need for planetary habitation, for planetary exploration. Whether it's human or robotic, we need that in any location, regardless of environment. And the fission power system that we're looking at is one of those solutions for us. So it's very promising. They're relatively small and lightweight and very powerful, like I said. So again, very enabling technology for us, but they're new. And when anything, when you have anything new like this, you have to go through a certain process. And that's what space technology, my organization at NASA headquarters, does. We take usually something from concept through a flight demonstration to prove it in what we call the relevant environment it needs to operate in. It's a means of risk reduction. So you're not using something you desperately need the first time you need it. You need to prove it up first and make sure that it's not going to fail. So like I said, we're in formulation with this. We're in the process of just looking at what's the schedule we need it on, what funding do we need for it. And then part of my job is to go out and advocate for all of that, for the resources needed to produce this throughout its lifetime.
Well, you mentioned other applications for the fission technology. I would love for you to talk about what you see happening there.
Yeah, so there's a lot of interest from some terrestrial applications that are interesting in terms of defense applications. Like I said, these are small power systems that you can, drop down potentially and use in situ where you need them on a temporary basis. So there's field applications for these in defense. I think there's mining applications for certain mining types of operations. So there's a lot of potential partnerships here that are pretty interesting.
That's very cool to bring it back from space to Earth. NASA's so good at that, giving us technologies that we end up using here every day.
Right. We have a long history of that.
Trudy, what's your favorite example of that?
Could be dating myself here in saying this, but do you remember the Bowflex technologies? Do you remember the Bowflex commercials and that kind of whole revolution? I think it was in the 2000s.
Yeah, of course.
So they're the inventor for that by the name of Paul Francis, and he developed this weightlifting system that doesn't use weights. So there's, it's compact and it's this resistant weightlifting system. And it was, designed then ultimately for use by astronauts using springs and pneumatic cylinders. So kind of adopted from that. And so that was developed for NASA, but was spun off to companies like Bowflex, who produced that weightlifting system for people to then buy here on Earth. I don't know how many they sold, but I just remember a lot of those commercials. So Bowflex. The other one I would tell you, and that space tech has and has a lot to do with, is a bunch of different technologies, but a few I'll mention is sensor technology. So aerosol sensors that were developed for aerosol detection for fires, detecting fires in spacecraft. So we developed sensor technology to be able to detect potential fires. And then we have adapted that for human health and environmental monitoring applications. So wildfire management, firefighting, health and safety. And because of the size, weight, and power and the durability of these things, it became evident to NASA after developing these things for a spacecraft that we could do this for issues on the ground. And then there are other things like materials. There's a material that firefighters, and this again was developed originally for space, firefighters could put over them to protect them from fires, even if the fire is going right over top. And then we have some autonomous aerial systems that our aeronautics directorate has developed for us for monitoring wildfires. So there's a whole host of things that we can do for wildfire management. But one of my favorite things about that is the agency is really looking hard at being an integrator for all of this, kind of from detection to suppression, and then kind of lessons learned and kind of circling that back to improve these things. Because a lot of partners we work with on this are operational and they're just implementing certain things they need. But to have someone look at the whole system, I think is really important. And we're talking now like the Bowflex thing I think is interesting for human health. Yes. But now we're talking about saving people's lives with this technology. So you go from, hey, you need this for a spacecraft. And again, we're doing that there for, human life issues. But now we're talking terrestrial applications and Earth applications to be able to do this. And to me, it's really important. And just to circle back really quickly to what I said about this loop, how we do the technologies, how we apply them, and then how we build in lessons learned in that process. I'll say to anyone who will listen, the colleagues I work with at NASA are some of the best systems thinkers and best analysts, critical thinking skills and analytical skills that I've ever met. And to me, it's a national resource to as an agency to have people and the whole, aerospace community. Because if you really think about it, aerospace is a system. So if you can understand that, you kind of understand how to think as a systems person. And I think it's a really critical skill set we need, just as human beings in general, too.
Really well said. That's incredible. I'm thinking about how bad the last several years of wildfires have been. So you bringing that up is just really poignant. I
want to circle back on something that you mentioned, surviving the lunar night. Can you expand a little bit more on how fission can help with that specifically?
Right. So the environments of space and lunar surface are, extremely cold. When we test things in a chamber that simulates temperatures and pressures of space, we usually cycle it between something like minus 300 degrees Fahrenheit to a positive, 300, 350 degrees, because you have the sun exposure, right? And not the same atmosphere as we have on Earth as on the moon. So you have a lot of exposure there to the sun. So it makes it very, very cold and very, very hot. And then just the extreme low pressures of space. So surviving that lunar night and the extreme temperatures, that's what I mean. That's what I mean by that. So if you have a fission surface power system or a fission system that works on the chemical process that I talked about with uranium, then it gives you a sustainable power source that's operating constantly to power your habitat. Potentially, you could have, astronauts living inside, where, again, it's not dependent on the sun, not dependent on chemicals, those types of things. So that's what I mean by kind of surviving the lunar night, as well as the equipment, the hardware you have up there you need to keep warm, that kind of thing.
It's making me think about The Martian.
Yes.
And Matt Damon and his RTG.
RTGs are part of our radioisotope power systems program, MMRTGs. We've flown those for so long, and they're very, very proven. The technology readiness level 9 technologies is what we call that, which means they are the top of the levels that we need to prove out. That means they're just flown all over and over again, and they're highly reliable. So,
what are you most excited about in the near future for space exploration?
Oh gosh, so many things. I mean, we've been talking a lot about, nuclear power and fission power and today, but like I said, there's just this broad range of technologies. I've had the privilege of working with people on optical comm. We have 2 optical comm technologies, payloads flying right now. One is orbiting, one's in low Earth orbit, orbiting the Earth. One is on its way out to and past Mars ultimately. If you haven't seen it, go back to just type in Taters the cat and go back to a video that we transmitted in December from this is the Psyche mission. It's a spacecraft that is headed out to a metal asteroid called Psyche. And we're flying this payload on there. We're a ride along. We just are along for the ride, and they're letting us test out this technology as they go out. So our goal is to get at least out to Mars and transmit back. And gosh, I think Taters was from 19 million miles away, and we've gone even further since then at higher data rates, high def video to come back. Because as you can imagine, once we put humans on Mars, we are going to need to know how they're doing, and we're going to need to know quickly. And so we're going to need very fast communications back and forth with them. So really excited about that. Also on Mars, we just had a really successful demonstration of the very first in-situ resource utilization technologies there. What that means is you are using resources you find in place at the time and making something out of them. This was a very small box that we flew on the Mars Perseverance rover that's still, up there, tootling around up there. And this took carbon dioxide and generated oxygen out of it, which is a critical technology for breathable systems, for fuel that we're going to need to maybe have launch from Mars back to Earth to get things back here. It's going to be fairly important. And so that just happened. They had successful runs, met all of their requirements for 99% oxygen purity, and they ran even longer than we expected them to. So that was a huge success for us. Robotics and autonomy is going to be huge for both low Earth orbit, geosynchronous orbit, Mars applications, and robots are nothing new, but how we apply them is. So I just spent the last couple of years forming up a consortium. It's called the Consortium for Space Mobility and ISAM Capabilities, or COSMIC, which is entirely centered around satellite servicing, using robotics and autonomy to do that. Earlier, we talked about Artemis, and of course, we're heavily thinking humans or astronauts, back to the moon and ultimately to Mars. But to do all of that, this is going to have to be a partnership between humans and robots to do all of this. And I'm really excited about that robotic part of it. As much that we can service or maintain using robots on other planets or in space is going to be hugely important for us. So this consortium, it's all of government, industry, and academia getting together to talk about how we further this. What things do we need to do? What products do we need to produce? It's really to establish global leadership in space servicing, assembly, and manufacturing capabilities, and really making it a routine part of what we do in terms of space architectures and mission life cycles. So that's a really important effort. We just kicked it off last fall, and it's really just getting going. So there's a lot I'm excited about. Nuclear power is going to be at the forefront of all this, along with nuclear propulsion for rapid transit types of applications. So that's really going to be key to all of this. One of the most key things that we do.
Yeah, thanks for bringing up propulsion too, because there's a lot of exciting developments that you guys are just doing so much cool stuff.
We really are.
If you had the chance to go to space, would you go?
No, but I've thought hard about this. I really would not. I'm older, I think, than you gals are. If I might just make a guess at that. And I really enjoy my family life, and my kids are getting a little bit older. I have, almost adult kids, one in high school, but really, really grown up. And I enjoy seeing other people go, to enabling other people to go. But personally, do I want to go myself? Not really, unless I was the pilot or the commander. But if I'm not sitting in that driver's seat, I probably don't want to go. So maybe, I don't know, maybe if I could fly the thing, But if not, I'm not going to sit in the back and be like, how's it going up there? I'd ask a million questions. How are the systems? Are there any warning lights? Do we have to be worried about it? Like, I'm a worrier. So anyway, I've just told you way too much personal stuff about me.
Trudy, same. I am very happy with my feet on planet Earth. Feels great.
Okay, I have to circle back to something you guys were talking about earlier, because I'm guessing people are listening and are still wondering, what is crusty? You guys have to give a little bit more background on this.
Oh, gosh. It was one of the very first tests that we did of a fission power reactor using this process out in a DOE facility. So NASA does the designs for these things, but we are not certified to handle any type of nuclear fuel or anything like that. That is strictly in the jurisdiction of the Department of Energy. So I don't know, Jordan, if you can pull up the crusty acronym really quickly. Just the basics of it was a ground-based test we did here on Earth at a facility out in Nevada of that technology.
Crusty stands for kilopower reactor using Stirling technology.
Very good.
They got the Y from the Y in technology.
Yes. Thank you for that.
It's really cool because it was like one of the first times you started hearing nuclear come up again in the context of space. You saw the shift. Like, NASA was very interested in nuclear technology back in the 60s. I'm not going to bore everyone with my nerdy history.
No,
but
this is good.
The nuclear rocket program, which was under development, and then they moved away from it, and then they started coming back. And so Crusty was really exciting because it was like, oh, we're talking about nuclear again in space, and there's so many good applications. So, and yes, they tested it out in Nevada.
Very good.
Was when I was there.
See, that was really a question for Jordan, not me. So I love that you know the history. That's really, really good. Yeah, and we did comes in cycles. We did get away from it for a while, and even using the kind of word nuclear, and then it came back as kind of more acceptable. So
we're hoping it's here to stay this time.
It sure seems that way.
Okay, before we go, we're having a food-centric ending question this season. I know you said you're in DC at your office today. You also live in Ohio. What is your favorite restaurant in the area? You can say DC, you can say the Cleveland area, or both.
Okay. You know what? I think I'll do both because I clearly spend more time in the Cleveland area. There's a restaurant there we really love called Pure W, and they've got a great happy hour. It's right on the water. You have a really beautiful view of downtown Cleveland on a nice clear day. And like I said, the happy hour is really great. And the setting is just unbeatable. So I really like that one. My family likes that one. Here, let's see. There's a place called Circa, I think at Foggy Bottom, George GW.
Yes.
I like that place. Oh, gosh. Pizza Paradiso. There's so many. Oh, you know what? I'm going to tell you this one because my friend, a friend of mine who has lived in DC a long time, introduced me to Lebanese Taverna. She also took me to a place called Pied du Cochon. It's the feet of the pig. I don't know if it's there anymore, but we had fun with that because we also went through French class together in high school and learning to speak French. So we were just thrilled that there was a restaurant in DC with a French name to it. Anyway.
No, we love it.
Well, that's great.
We're collecting all of these exciting restaurants. So.
When Mary and I are in Cleveland next, we're going to do happy hour on the water with you, Trudy.
That sounds really good. I will make the reservation and we'll go to Pier W for happy hour. How's that?
Love it.
That sounds amazing. Great conversation with Trudy. We're going to have her back at some point. There's so much more to talk about with nuclear and space. If you are interested in learning more about any of the NASA programs Trudy talked about today, visit NASA's website. And if you want to learn more about Trudy and her work, her website is linked in our show notes.
And don't forget to rate and subscribe to the podcast on Apple or wherever you get your podcasts. Thanks for listening. See you next time.